AB Calculus BC, Unit 7, Day 11, Office Hours. This is Part 2 of the pretest. So we got a little Fundamental Theorem of Calculus Part 2 here. These are quick, easy problems. You derivatives undo integrals, plug limit in. But watch out, you got to multiply by the derivative of what you plugged inside afterwards. It's chain rule. So that goes away. Your final answer is negative cosine x. Next one. Plug it in, sine x squared. I like to put it in its own parentheses, minus sine of 2x squared, because when you multiply by the derivative of what you plugged in, it's just the thing you plugged in, not x to the fourth, x squared. So you get 2x, not 4x squared, just the derivative of 2x, 2. So final answer, you can simplify it, 2x sine x to the fourth minus 2 sine 4x. That's it. Quick and easy. I think not that complicated. Okay, integrals of absolute values. This is linear, so we could do it three ways. We could do it with geometry by graphing it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so starts at -6. I'm going to graph line without the absolute values. Up 2 over 1, 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 up 2 over 1. So this is the line, and then the absolute value flips the negative part up, makes it positive. So you get these V-looking graphs. Now we want to integrate 1 to 6. This is 3, 4, 5, 6. I wouldn't try and rely too much on the picture. I would rely on the slope to make sure you got it right. So it's 1/2. Its triangle base is 2. Height is, slope is 2, right? So if you go over 2, it should be up 4. Plus 1/2. The base of the next one is 3. The height is, if you go over 3, you went up 6. So then your pictures don't have to be perfect. 4 plus 9 is 13. So that's one way to do it. Another way is kind of the typical way that you can apply to any problem. You could, integrate it. What you would do is you would find the zeros of the function, the x-intercept. So you would factor it, set it equals 0, factor it. X equals 3 tells you that you're going to break it up at 3 because it's going to change sign at 3. That's an x-intercept. That's what we did on the picture. And then you can do a line check. Test a point. X equals 4, positive, negative. So now you can rewrite it. You can say, all right, we're going to go from 1 to 3, drop the absolute values, 2x minus 6. And then we're going to go from 3 to 6, drop the absolute values, 2x minus 6. That's the whole point of doing this, is get rid of the absolute values. So it shouldn't be there anymore. The negative part, you got to fix it by putting an extra negative in the front. And then you just go ahead and integrate it. Now there's a shortcut approach I'm going to show you in a second. 2x squared over 2 minus 6x, 1 to 3. 2x squared over 2 minus 6x, 3 to 6. So we get negative. We plug 3 in, you get a 9 minus 18 minus 1 minus 6 plus 36 minus 36 minus 9 minus 18. So this is going to be negative 9. It's going to be negative 5. There's 2 negatives, so this is going to be negative 4. That's the negative part that gets fixed, which makes sense. This is going to be negative 9. That's going to be positive 9. That one is positive. So you have 4 plus 9 is 13. Works. Same answer. Now there is another way of doing that. You would still find the zeros. but you would use a table. And you could probably skip the line check unless it's something involves trig. You probably would. And you put 1, 3, 6 on here, and then you put x, and then you'd integrate it without the absolute value. You're doing the same work. You're just not going to do it over and over and over again like you did before. Before we had to integrate it twice. We had to plug in 3 twice. Here we integrate it once. We plug in 1 once, 3 once, 6 once. We do everything one time. So it's going to be 1 minus 6 is negative 5, and then 9 minus 18 is negative 9, and 36 minus 36 is 0. And you find the distance between negative 5 and negative 9 is positive 4. Distance is always positive. 9, you add them up, 4 plus 9 is 13. So it takes out some of the repetitive work. Also, I think just the organization of the table kind of makes it a little easier to do than all these long lines of numbers and stuff. So 3 different ways, same answer every way. Now this one's not linear, so we can't do geometry. So we could set it equal to 0 no matter what. Those other two approaches rely on the zeros. Alpha equals pi over 6, quadrant 1, quadrant 2. You guys should be great at trig by now. X equals pi over 6 plus 2 pi k. I'm just very thorough in trig. X equals 5 pi over 6 plus 2 pi k. So we just want the values between 0 and pi. So that's going to be pi over 6 and 5 pi over 6. So you can do a line check. If I'm doing it either of these ways, I'm going to do a line check for this because the values are going to be really ugly, irrational values. And I don't think I'm going to so easily figure out the distance between them in my head like I did when they were just rational numbers. Test the value. X equals 0 is my favorite for trig. Test it in here. Sine of 0 is 0. Minus 1 is negative, positive, negative. So what that means is we're going to go 0 to pi over 6, 2 sine x minus 1 dx. And then we're going to go pi over 6 to 5 pi over 6, 2 sine x minus 1 dx. And then we're going to go 5 pi over 6 to pi of 2 sine x minus 1 dx. Ugh. 3 separate intervals. That table is going to save us a lot of work compared to this, but I'll go and do it this way. Negative 2 cosine x minus x, 0 to pi over 6, plus negative 2 cosine x. It's the same antiderivative every time. So, I mean, even though we're doing it over and over again, I mean, you could just say, oh, we already did that. It's the same thing. Negative 2 cosine x minus x, 5 pi over 6 to pi. And we've got to plug these things in. So negative 2 cosine pi over 6 is root 3 over 2 minus pi over 6. Minus, you plug 0 in. Cosine 0 is 1, so it's going to be negative 2 minus 0. Plus negative 2 cosine of 5 pi over 6 is root 3 over 2, but it's in quadrant 2, so it's negative root 3 over 2 minus 5 pi over 6. Minus plug pi over 6 in. Negative 2 cosine pi over 6 is root 3 over 2 minus pi over 6. Plus, or should I do it over here? Just try and fit all this in over here. Negative 2 cosine of pi is negative 1 minus pi. Minus negative 2 cosine of 5 pi over 6 is negative root 3 over 2 minus 5 pi over 6. Now we got to simplify all that. Okay, well, those 2's cancel every time. Oh, that's nice. Okay, so I have negative 2 root 3. No, I have negative root 3 and a positive root 3. Those guys cancel each other out, right? Then I got positive root 3 and I got negative root 3 again. So those guys cancel out. So I think all do the root 3's really cancel each other? That's negative. That's positive. Minus, that's positive. That's negative. It seems like they all cancel each other out. Oh, shoot. I never fixed it. So this one is supposed to have a negative in front, and this one's supposed to have a negative in front. So it means we have an extra negative in front of this, extra negative in front of this, extra negative in front of this, all of this, extra negative in front of all of this. So this is positive root 3. This is positive root 3. This is positive root 3. And this is positive root 3. So we have 4 root 3. Okay, 4 root 3. We have this positive 2, but it's a negative 2. And then another negative 2 there. So that's negative 4. And then the pi over 6 stuff. We have a positive pi over 6, negative 5 pi. So that's negative 4 pi over 6, negative 3 pi over 6, negative, I don't know, I can't even keep track of all the stuff. So we have a positive pi over 6, negative 5 pi over 6, positive pi over 6. And then this would be positive pi and negative times the negative is positive, but then there's another negative, so it's negative 5 pi over 6. So we have 8 pi over 6 minus 10 pi over 6. That's minus 2 pi over 6. Final answer, 4 root 3 minus 4 minus pi over 3. Table's going to make that a little nicer. It's still going to be annoying. But 0, pi over 6, 5 pi over 6, pi x. We're going to integrate it once instead of 3 times. So that's nice. Negative 2 cosine x minus x. Plug 0 in, you get negative 2. Plug pi over 6 in, you get negative 2 times root 3 over 2 minus pi over 6. Plug 5 pi over 6 in, you get negative root 3 over 2 minus 5 pi over 6. So we get positive root 3 minus 5 pi over 6. And then plug pi in, and cosine of pi is negative 1 minus pi. So we get 2 minus pi. Now, when you go to find the distances between these are all crazy, ugly numbers that you don't want to estimate or anything like that. So that's where the line check comes in. We know this is a negative part. This is a negative part. So the easy way to fix it is to, instead of doing upper limit minus lower limit, go backwards. So it's got to be negative 2 minus this. So it's going to be negative 2 plus root 3 plus pi over 6. The next one is normal. So we do this minus that. And so we get 2 root 3, negative 5 pi over 6 plus 5 over 6 minus 4 pi over 6. And this one we do backwards. So we get root 3 minus 2, and negative 5 pi over 6 minus pi would be, minus negative pi would be positive pi over 6. So now we add all these together, and we get 4 root 3 minus 4 minus 2 pi over 6 would be negative minus pi over 3. So same answer. I think that's definitely a lot better, but you just got to be careful. Rectilinear motion, one-dimensional motion. You have acceleration, you have initial velocity, initial position. I think, using the table to find displacement and distance is your best bet. You can go all the way down and find, displacement is going to be S3 minus S0. It's very simple, straightforward, but it's a bit of work to find the position function, which I think we could avoid. So instead, I'm going to do the integral of velocity dt and use the table to help me. And here we're going to do the integral of the absolute value of velocity, or speed, from 0 to 3. And the table is going to be helpful for that because it's the same table we use for other absolute value functions. We do need to find the velocity function. So velocity is going to be the integral of v prime, which is going to be the integral of a, which is going to be the integral of 2t minus 6 dt, which is going to be 2t squared over 2 minus 6t plus c. We have initial condition, so we're going to use that to find the c value. And c equals 5. So our velocity equation is t squared minus 6t plus c. Now, you don't need to use the table to do this. You can just treat this like no problem. Make sure you know how to use these shortcuts if you are. So I'm gonna find the zeros of this. I'm gonna factor it t minus 1, t minus 5, t equals 1 and 5. I'm interested in 0 to 3. So I'm gonna make a table 0, 1, 3, 5. I can ignore the 5, it's outside the endpoints. T, we're gonna integrate velocity, t squared minus 6t plus 5 dt. And that's going to give us t cubed over 3 minus 6t squared over 2 plus 5t. So this is, you're on the path to finding the position function, but we kind of like bail and don't find the c value and use the table to kind of make everything nice. It's going to be 0. If you do 1, it's 1/3 plus 2, so that's 2 and 1/3, that's 7/3. Plug 3 in, you get 9 minus 27 plus 15. So that is 24, that's -3 or -9/3. And so distance here is 7/3, distance here is 16/3. And so the total distance is 23/3 or 7 2/3. That's distance. Displacement would just be the final one, -9 or -3 minus the initial one 0, which is going to be -3. Displacement can be negative. Distance can never be negative. So that's using the table to find both of these, which I think is worth it. Okay, last page. Some more motion stuff. This is velocity. Initial condition for position. When is Johnny slowing down? So that's acceleration and velocity have opposite signs. So doing line checks for these would be good. Now, we could find acceleration. Acceleration is 3t squared minus 12t plus 9. So it equals 0 to find its zeros. Factor a 3 out, t squared minus 4t plus 3. Keep going. T minus 1, t minus 3. So t equals 1 and t equals 3. So the line check for this, make sure you label your line checks. 1, 3, test a value, t equals 4, positive, negative, positive. Then acceleration, or then velocity, we need to factor this. So we take a t out, t squared minus 6t plus 9. And then we keep going, t minus 3, t minus 3. So t minus 3 squared, which you don't have to do, but that might help you to realize that that is a double root, and it's going to bounce off the line. I'm going to put it right below this one and try and line them up. So 0 would be over here relative to 1, and then we have 3 should line right up with this. I'm going to test t equals 4. Now remember, this one doesn't change. So it's going to be positive, positive, negative. So where do they have opposite signs? Over here, here. Okay, now negative infinity to 0, and then 1 to 3, but we don't want to include negative time on these problems. So it's just going to be 1 to 3. That's the work. maximum velocity. So this is extreme value theorem. These are your endpoints. We got to find critical points. So you got to take the derivative of the thing you're trying to maximize, which is going to be acceleration this time, which is 3t squared minus 12t plus 9, so equal to 0, which we already did this. I guess I could redo it if you want. So these are your critical points for velocity. So we're going to make a table. So table t, we're plugging it into velocity, the thing we're trying to maximize, minimize. I like to write these formulas down here. So endpoints are 0 and 5, critical points. So we got to plug all these in. So we get 0. Plug 1 in, you get -5, you get 4. Plug 3 in, you get 27 minus 54 plus 27, which is 0. Plug in 5, you get 125 minus 6 times 25 would be 150 plus 45. -25 is 20. So we're looking for the max. There's the max. It's at one of the endpoints. This is the min that happens multiple locations. So we're going to write the answer. Nice, I guess. The maximum velocity is 20. Oh, we don't have units on here. When time t equals 5 by extreme value theorem by checking endpoints and critical points. Okay. Straightforward, extreme value theorem, average velocity. So there's different ways to do average velocity. You could do v average, and you could do just the average of a function. Integrate this, 0 to 2, divide by the base. But velocity, well, I think that might be our best bet, because otherwise you need the position function. If you're going to do, you could do v average equals s prime average, and then do s2 minus s0 over 2 minus 0. The thing about that is we don't have a position function yet. If we already had it, I would go with that, but we don't. And the work to find this is going to be the same work here plus more. So I think I'm just going to go with this. 0 to 2, t cubed minus 6t squared. I mean, it's similar work, but I feel like, and usually if you had s, this would be a lot quicker, but we don't. So this is probably going to be a little quicker. Antiderivatives t to the fourth over 4 minus 6t cubed over 3 plus 9t squared over 2. 0 to 2. So we're going to plug 2 in. That's going to be 16 over 4 is 4 minus 2 times 8 is 16 plus 4 times 9 is 36 divided by 2 is 18. And then plug 0 in. It's going to be 0 minus 0 plus 0. Just checking. Sometimes you plug 0 and you actually get something out. This is going to be 1/2 of 6 is 3. That's your average value. You can do it this way, but you're going to do the same kind of work plus more, because you got to find the c value, and I don't think it's worth it. Total distance. Total distance is the integral of the absolute value of velocity. It's good to just write down your setups, which is also the integral of speed, by the way, which applied also to parametrics this year. So I'm going to use the table approach, but velocity equals t cubed minus 6t squared plus 9t. And we want to find its zeros. So we factor t out, t squared minus 6t plus 9. We already did this earlier, by the way. T minus 3, 2 minus 3. t equals 0, and t equals 3. But that's a special balance, which would matter if you're going to do a table. But I feel like we could, with this, we're going to get pretty nice answers. Now, a table is just going to be 0 to 2. We don't even care about the 3, actually. And we're integrating velocity, t cubed minus 6t squared plus 9t. And so that's going to be t to the 4th over 4 minus 6t cubed over 3 plus 9t squared over 2. And we plug 0 in and we get 0. Plug 2 in, you get 16 over 4 is 4 minus 2 times 8 is 16 plus 18. So that's 6. So total distance is 6, which is also the displacement. But there you go. That's it. Make sure you're ready for your test. Both parts, some calculator, some not. All the motion stuff was on part 2, no calc. So this is all part 2, no calc on your test. On the front, or sorry, on the previous page, I didn't write it, but rectilinear motion, part 2, no calc. Absolute values are going to be on the no calc because otherwise you wouldn't have to, you just plug in your calculator. So absolute values is part 2, no calc. Fundamental theorem and calc is part 2, is probably part 2, no calc. The calculator's not going to help you with it, even if it is on the other part. So that's it. Be ready.